Even subject ME 8492 kinematics of machinery, 5th unit, friction in machine elements. In that 5th unit we are going to discuss about the belt and the rope drives. In belt drives, power transmitted by the belt, how the power is transmitted in the belt drives. See the diagrams. A driving pulley A and the driven pulley B. We already discussed that the driving pulley pulls the belt from one side and it delivers the same to the other side. It is thus obviously that the tension on the tight side will be greater than the slack side. It is T1 and T2 are the tensions in the tight and slack side, and R1 and R2 are the radii of the driver and the follower respectively. V is the velocity of the belt. The effective turning force at the circumference of the follower is the difference between the two tensions, that is T1 minus T2. The work done per second, W is equal to T1 minus T2 into V, Newton meter per seconds. Power transmitted, P is equal to T1 minus T2 into V into W. A little consideration will show that the torque exerted on the driving pulley, that is T1 minus T2 into R. Next one, we are going to see the problems. Next one is problem in power transmission for the belts. Find the power transmitted by the belt running over a pulley of 600 mm diameter at 200 rpm. The coefficient of friction between the belt and the pulley is 0.25 and the angle of lap 160 degree and the maximum tension is in the belt is 2500 Newton. Write down the given details. D, N, mu, theta. Convert the theta values into radians, and T1 maximum tension in the belt. T1 is equal to 2500 Newton. We know that the velocity of the belt V is equal to pi dn divided by 60. Substituting these values, we get the velocity of the belt V is equal to 6.284 meter per second. We know that the 2.3 log of T1 by T2 is equal to mu theta. Substituting these values, we get the T1 by T2 is equal to 2.01. Taking anti-log of 0.3036, we are getting T1 by T2 is equal to 2.01, and solve this value. Rewrite that T2 is equal to T1 divided by 2.01. we already know given T1 is equal to 2500 Newton, so T2 will be 1244 Newton, and power transmitted P is equal to T1 minus T2 into V. Substituting the values of T1, T2 and V, are getting power transmitted P is equal to 7.89 kilowatt. And we are going to the next problem. A casting weighing 9 kilonewton hanging freely from a rope which makes 2.5 turns around a drum of 300 mm diameter revolving at 20 rpm. The other end of the rope is pulled by a man. The coefficient of friction is 0.25. Determine the force required by the man and the power to raise the casting. Solution. First, write the given details. That is weight, casting weight 9 kilonewton, that is T1, 9000 Newton, diameter, and N 20 rpm, mu 0.25. Force required by the man, let this be the T2. T2 is the force required by the man. Since the rope makes 2.5 turns around the drum, therefore angle of contact theta is equal to 2.5 into 2 pi, that is 5 pi radians. We know that the 2.3 log of t1 divided by t2 is equal to mu into theta. Substitute these values for getting the t1 by t2 is equal to 51. We already know the t1 value 9000 Newton. Substituting these values in t1 divided by t2 is equal to 51. t2 is equal to 176.47 Newton. The second one is the power to raise the casting. We know that the velocity of the rope v is equal to pi dn divided by 60. So v is equal to 0.3142 meter per second. Power to raise the casting P is equal to T1 minus T2 into V. Substituting these values for getting the power, P is equal to 2.772 kilowatt. And the next problem, a shaft rotating at 200 rpm drives another shaft at 300 rpm and transmits 6 kilowatt through a belt. The belt is 100 mm wide and 10 mm thick. The distance between the shaft is 4 meter. The smaller pulley is 0.5 meter in dia. Calculate the stress in the belt if it is first an open belt drive and the cross belt drive. Take mu is equal to 0.3. Calculate the stress in the belt for open condition and also in the cross belt drive condition. Write the given details. N1 N2 P B T is equal to 10 mm, X distance 4 meters, mu 0.3. Let sigma is the stress in the belt. We have to find the stress in the belt for an open belt drive. Let us find out the diameter of the larger pulley D1. N2 divided by N1 is equal to D1 divided by D2. Substituting the given known values for getting the D1 is equal to 0.75 meter and the velocity of the belt V is equal to pi D2 N2 divided by 60 and V is equal to 7.855 meter per second. Now let us find the angle of contact on the smaller pulley. We know that for an open belt drive, sin alpha is equal to R1 minus R2 divided by X. By solving these values, you have to find out the alpha value. Alpha is equal to 1.8 degree and the angle of contact theta is equal to 180 minus 2 alpha. So theta value is equal to 176.4 degree. In order to convert into radians, 3.08 radians theta value. Let T1 is the tension in the tight side of the belt and T2 is the tension in the slack side. We know that 2.3 log T1 divided by T2 is equal to mu theta. Log of T1 by T2 is equal to calculate the values mu into theta, that is 0.924 divided by 2.3. So T1 divided by T2 is equal to 2.52. Taking anti-log of 0.4017, we know that the power transmitted P is equal to T1 minus T2 into V. We already know the power transmitted, that is 6 kilowatt, is equal to T1 minus T2 into V. By solving this, we have to find out the T1 minus T2 is equal to 764 Newton. By solving this equation 1 and 2, we are going to get the tension in tight side. T1 is equal to 1267 Newton and T2 is equal to 503 Newton. We know that the maximum tension in the belt, that is 1267. Is equal to sigma B into T. We have to find the sigma value 1.267 megapascal, and stress in the belt for the cross belt. Now we are going to discuss the stress in the belt for the cross belt. The same type, the cross belt drive, sin alpha is equal to r1 plus r2 divided by x. By solving these values, you are getting alpha is equal to 9 degree and the angle of contact theta is equal to 180 degree plus 2 alpha. So theta is equal to 3.456 radians. We know that 2.3 log of t1 by t2 is equal to mu theta. By solving these values, we are getting t1 divided by t2 is equal to 2.82. That is equation number 3. Substituting the equations 2 and 3. By solving t1 is equal to 1184 Newton and t2 is equal to 420 Newton. We know that the maximum tension in the belt 1184 is equal to sigma bt. By solving the given values, sigma is equal to 1.184 megapascals. And next, move on to the next problem. Determine the width of 9.75 mm thick leather belt required to transmit 15 kilowatt from a motor running at 900 rpm. The diameter of the driving pulley of the motor is 300 mm. The driven pulley runs at 300 rpm and the distance between the center of two pulleys is 3 meters. The density of the leather is 1000 kg per meter cube. The maximum allowable stress in the leather is 2.5 megapascal. The coefficient of friction between the leather and the pulley is 0.3. Assume open belt drive and neglect the slag and the slip of the belt. First write the given details. The next one, first of all, let us find out the diameter of the driven pulley D2. We know that N2 divided by N1 is equal to D1 divided by D2. In this equation, we are going to get the D2 values. D2 is equal to 0.9 meter and the velocity of the belt V is equal to pi D1 N1 divided by 60. So velocity is equal to 14.14 meter per second. For an open belt drive, sin alpha is equal to R2 divided by R1 divided by X. So alpha value is equal to 5.74 degree and the angle of lap theta is equal to 180 degree minus 2 alpha. So theta is equal to 2.94 radians. Let us T1 and T2 are tension in the tight and the slack side respectively. We know that 2.3 log of T1 divided by T2 is equal to mu theta. By solving these known values for getting the T1 by T2 is equal to 2.42, that is equation number 1. As we know that the power transmitted 15 kilowatt is equal to T1 minus T2 into V. So we are getting T1 minus T2 is equal to 1060 Newton. By solving the equation 1 and 2, we are getting the T1 value. T1 is equal to 1806 Newton. Let be the width of the belt in the meters. In meters, we know that the mass of the belt per meter length M is equal to area into length into density, that is B into T into L into density rho. So M is equal to mass of the belt per meter length is equal to 9.75 B kilogram. So that is the centrifugal tension T is equal to mv square. M mass 9.75 B into V square. We already know the velocity 14.14 the whole square. So TC is equal to 1950 into B Newton. Maximum tension in the belt T is equal to sigma BT. Solving the given details, maximum tension T is equal to 24,400 B Newton. We know that T is equal to T1 plus TC or T1 minus TC is equal to T1. By solving the given details, maximum tension T 24,400 B minus 1950 B is equal to 1806. So we have to find the B. B is equal to 80 mm. Next, move on to the next problem. Two parallel shafts whose center lines are 4.8 meter apart are connected by the open belt drive. The diameter of the larger pulley is 1.5 meter and that of smaller pulley 1 meter. The initial tension in the belt when stationary is 3 kN. The mass of the belt is 1.5 kg per meter length. The coefficient of friction between the belt and the pulley is 0.3. Taking centrifugal tension into an account, calculate the power transmitted when the smaller pulley rotates at 400 rpm. Write down the given details. X d1 d2 t naught and m 1.5 kg per meter, mu 0.3 and n2 400 rpm. We know that the velocity of the belt v is equal to pi d2 into n divided by 60. Substituting these given values for getting the velocity of the belt, v is equal to 21 meter per second and the centrifugal tension Tc is equal to mv square. We already know the mass and v velocity of the belt. So Tc is equal to 661.5 Newton. Let us T1 and T2 are the tension in the tight and the slack side of the belt. We know that the initial tension T0 3000 is equal to T1 plus T2 plus 2 Tc divided by 2. So T1 plus T2 is equal to 3000 into 2 minus 2 into 661.5. That is T1 plus T2 is equal to 4677 Newton. That is equation number 1. For an open belt drive, sin alpha is equal to R1 minus R2 divided by X. So alpha is equal to 3 degree. Angle of lap on the smaller pulley, theta is equal to 180 degree minus 2 alpha. So theta is equal to 3.04 radians. We know that 2.3 log of T1 divided by T2 is equal to mu theta. By solving this equation, we are getting T1 divided by T2 is equal to 2.5. Taking is that equation number 2. By solving equation 1 and 2, we are getting the T1 and T2. Tension in the tight side, T1 is equal to 3341 Newton and T2 is equal to 1336 Newton respectively. And power transmitted P is equal to T1 minus T2 into V. By solving this value, we are getting the power transmitted P is equal to 42.1 kilowatt. And next we are going to power transmitted P is equal to 42.1 kilowatt. And next we are going to the next belt section, that is V belt. V belt are made of fabric and cords molded in the rubber and covered with a fabric and rubbers as shown in this figure. These belts are molded to a trapezoidal shape and are made endless. These are particularly suitable for short drives, that is when the shafts are at a short distance apart. The included angle of the V belt is usually from 30 degree to 40 degree. In the case of fat belt drive, the belt runs over the pulley, whereas in the case of V belt drive, the rim of the pulley is grooved in which the V belt runs. The effect of the grooves is to increase the frictional grip of the V belt and on the pulley, and thus reduce the tendency of the slipping. The power is transmitted by the wedging action between the belt and the V groove in the pulley. Diagram shows the V belt drive and V groove pulleys. The next one, the advantages and disadvantages of the V belt over the fat belt drive. The V-belt drive gives the compactness due to the small distance between the centers of pulleys. The advantages, and the drive is positive because the slip between the belt and the pulley groove is negligible. Since the V-belts are made endless and there is no joint trouble, therefore the drive is smooth. It provides longer life up to 3 to 5 years for V-belt drives. It can be easily installed and removed. The operation of the belt and the pulley is quite. The belts have ability to cushion the shock when the machines are started. The high velocity ratio may be obtained maximum 10. The weighing action of the belt in the groove gives the high value of limiting ratio of the tensions. And next one is what are the disadvantages of the V-belt over the flat belt. The V-belt drive cannot be used with a large center distance. The V-belts are not so durable as flat belt. The construction of the pulleys for V-belt more complicated than the pulleys for the flat belt. Since the V-belts are subjected to a certain amount of creep, therefore these are not suitable for constant speed applications such as synchronous machines and timing devices. The belt life is greatly influenced with the temperature changes, improper belt tension and mismatching of the belt length. The centrifugal tensions prevents the use of V-belts at a speed below 5 meter per second and above 50 meter per second. And now move on to the problems in V-belt drives. A belt drive consists of two V-belts in parallel on grooved pulley of the same size. The angle of groove is 30 degree. The cross-sectional area of each belt is 750 mm square and mu is equal to 0.12. The density of the belt material is 1.2 mg per meter cube and the maximum safe stress in the material is 7 megapascals. Calculate the power that can be transmitted between the pulleys 300 mm diameter rotating at 1500 rpm. Find also the shaft speed in rpm at which the power transmitted would be maximum. First going to rewrite the given details. Power transmitted, we know that the velocity of the belt V is equal to pi d n divided by 60. So velocity of the belt V is equal to 23.56 meter per second and mass of the belt per meter length M is equal to area into length into density. Area 750 into 10 power minus 6 into length 1 meter and density rho is equal to 1200. So mass of the belt per meter length M is equal to 0.9 kilogram per meter. Centrifugal tension Tc is equal to mv square. We already know m and v. So by solving this in the centrifugal tension Tc is equal to 500 Newton. We know that the maximum tension in the belt, maximum tension is equal to maximum stress into cross sectional area of the belt, that is maximum stress sigma into cross sectional area of the belt A. Maximum stress 7 into 10 power 6 and cross sectional area 750 into 10 power minus 6. So maximum tension in the belt T is equal to 5250 Newton. Tension in the tight side of the belt T1 is equal to T minus Tc. We already know maximum tension T and centrifugal tension Tc. So tension in the tight side T1 is equal to 4750 Newton and tension in the slack side T2 is equal to, we know that 2.3 log T1 divided by T2 is equal to mu theta cosecant beta. Here log of T1 by T2 is equal to 0.6334, taking anti-log of 0.6334. Now T1 divided by T2 is equal to 4.3. By solving these equations we are getting T2 value. Tension in the slack side T2 is equal to 1105 Newton. we know that the power transmitted P is equal to T1 minus T2 into V into twice, so number of belt is equal to 2. By solving these values, for getting the power transmitted P is equal to 171.752 kilowatt, that is 171.752 kilowatts. And next move on to the shaft speed. Let N1 is the shaft speed in RPM, V1 is the belt speed in meter per second. We know that the maximum power and the centrifugal tension, so Tc is equal to T by 3. So we are getting, by solving these equations, V1 is equal to 44.1 meter per second. We know that the belt speed V is equal to pi dn divided by 60. So we are getting the, here we have to find the V1. So velocity pi d n1 divided by 60. So n1 is equal to 2809 rpm. Now move on to the next problem. A power is transmitted using a V belt drive. The included angle of V groove is 30 degree and the belt is 20 mm deep and maximum width is 20 mm. If the mass of the belt is 0.35 kg per meter length and the maximum allowable stress is equal to 1.4 megapascal, determine the maximum power transmitted when the angle of lap is 140 degree. Then mu is equal to 0.15. Write the given details. V groove, the included angle V groove, that is 2 beta is equal to 30 degree, so beta is equal to 15 degree. Included angle is the beta. We know that the maximum tension in the belt T is equal to sigma Bt. We already know the sigma values, B value and T values. So maximum tension T is equal to 560 Newton. For maximum power to be transmitted, the velocity of the belt V is equal to square root of maximum tension T divided by 3m. T1 is the tension in the tight side, T2 is the tension in the slack side. So maximum power transmitted and the velocity of the belt V is equal to 23.1 meter per second. We know that 2.3 log of T1 divided by T2 is equal to mu theta into cosecant beta. By solving this value, we have to find the T1 divided by T2 is equal to 4.13. Consider it as equation number 1. And going to the centrifugal tension, Tc is equal to T divided by 3. We know that T is the maximum tension in the belt, that is 560. We already find that divided by 3, 187. So centrifugal tension Tc is equal to 187 Newton. By substituting this in, T1 is equal to T minus Tc. For getting T2, tension in the slack side 90.3 Newton. We know that the maximum power transmitted P is equal to T1 minus T2 into V. By solving this given values, for getting the maximum power, P is equal to 6.53 kilowatt. And move on to the next concept of rope drives. The rope drives are widely used where the large amount of power is to be transmitted from one pulley to another over a considerable distance. It may be noted that the use of flat belts is limited for transmission of moderate power from one pulley to another when the two pulleys are not more than 8 meters apart. If the large amount of power are to be transmitted by the flat belt, then it would result in excessive belt cross section. It may be noted that the frictional grip in the case of rope drive is more than in the V drive. One of the main advantages of the rope drive is that as the number of separate drives may be taken from one driving pulley. For example, in many spinning mills, the line shaft on each floor is driven by the ropes passing directly from the main engine pulley on the ground floor. These are the two types of the rope drives, fiber ropes and the wire ropes. The fiber ropes operate successfully when the pulleys are about 60 meters apart, and the wire ropes are used when the pulleys are up to 150 meters apart. Next one is the rope drives. Fiber drives. Ropes or transmitted powers are usually made from fibrous materials such as hemp, manila and cotton. Since the hemp and manila fibers are rough, therefore the ropes made from these fibers are not very flexible and possesses poor mechanical properties. The hemp ropes have less strength as compared to the manila fibers. The cotton ropes are very soft and smooth. The lubricator of cotton ropes is not necessary, but if it is done, it reduces the external wear between the rope and the grooves of its shears. It may be noted that the manila ropes are more durable and stronger than the cotton ropes. Advantages of the fiber rope drives: they give smooth, steady and quiet services. They are a little affected by outdoor conditions. The shaft may be out of strict alignment. The power may be taken off in any direction and in fractional parts of the whole amount. They give high mechanical efficiencies. And the next one is the ratio of driving tensions for the rope drives. That is, we have discussed in the ratio of the driving tensions is 2.3 log T1 divided by T2 is equal to mu theta cosecant beta. Move on to the problems in rope drives. A rope drive transmits 600 kilowatt from a pulley of effective diameter 4 meter, which runs at a speed of 90 rpm. The angle of lap is 160. The angle of groove is 45 degree. The coefficient of friction is 0.28. The mass of rope is 1.5 kg per meter, and the allowable tension in the each rope is 2400 Newton. Find the number of ropes required. First, write the given details. Power transmits, rope drive transmits P is equal to 600 kilowatt and diameter is equal to 4 meter and at a speed of 90 rpm, and the angle of lap, that is theta, is equal to 160 converted into radians, 2.8 radians, and cruise angle of groove 45 degree, that is 2 beta is equal to 45 degree. Then beta is equal to 22.5 degree and mu 0.28 and mass 1.5 kg per meter. And finally the tension in the rope, T is equal to 2400 newtons. We know that the velocity of the rope V is equal to pi dn divided by 60. By solving this given values, dia is equal to 4, n 90. So velocity of the rope V is equal to 18.85 meter per second, and centrifugal tension Tc is equal to mv square. We already know the given things: mass 1.5 kg per meter and v square. By solving these given values and find out values, centrifugal tension Tc is equal to 533 Newton, and tension in the tight side of the rope T1 is equal to T minus Tc, that is 2400 minus 553, that gives the tension in the tight side T1 is equal to 1867 Newton, and T2 is the tension in the slack side of the rope. So we have to find the T2. Now we know that the 2.3 log of T1 divided by T2 is equal to mu theta cosecant beta. By solving these given values, we have to find out the ratio format of tensions. T1 divided by T2 is equal to 7.786. By substituting this known value of T1, that is 1867, so tension in the slack side T2 is equal to 240 Newton. We know that the power transmitted per rope P is equal to T1 minus T2 into V. So power transmitted per rope is equal to 30.67 kilowatt. So number of ropes, that is total power transmitted divided by the power transmitted per rope, that gives power transmitted by the rope 600 divided by 30.67. So number of ropes is equal to 20 ropes. Next, move on to the next problem in ropes. A pulley used to transmit power by means of a rope has a diameter of 3.6 meter and has a 15 grooves of 45-degree angle. The angle of contact is 170 degree and the coefficient of friction between the ropes and the grooves sides is 0.28 and the maximum possible tensions in the rope is 960 Newton and the mass of the rope is 1.5 kilogram per meter length. We have to find what is the speed of the pulley in RPM and power transmitted if the condition of the maximum power prevails. Write down the given details, that is D number of grooves 15s and beta 22.5, theta in terms of radians 2.967 radians and mu 0.28 and mass 1.5 kilogram per meter. First, speed of the pulley. Let n is equal to speed of the pulley in RPM. We know that the maximum power, velocity of the rope and the pulley, V is equal to square root of T divided by 3m. T is the maximum possible tensions in the rope, that is 960. Maximum possible tensions T divided by 3 into mass. So we are getting the velocity V is equal to 14.6 meter per second and velocity V is equal to pi d n divided by 60. By solving these equations we have to find out the n, that is speed. N is equal to 77.5 rpm and power transmitted. We know that the maximum power transmitted, centrifugal tension T is equal to T by 3. The maximum centrifugal tension T is equal to 320 Newton. Tension in the tight side of the rope T1 is equal to T minus Tc, that is T1 is equal to 640 Newton and we have to find out the tension in the slack side T2 is equal to 2.3 log of T1 divided by T2 is equal to mu into theta into cosecant beta. By solving these known values in terms of getting the T1 divided by T2 is equal to 8.78 in fractions of tensions, and by solving the known value T1, that is 640, we already find that. So tension in the slack side T2 is equal to 73 Newton. So power transmitted per rope T1 minus T2 into V is equal to, by solving these given values, per rope is equal to 8.278 kilowatt transmit the power per rope. Since the number of grooves are 15, therefore the total power transmitted, that is per rope, power transmitted per rope into number of grooves, that is 124.17 kilowatt power has been transmitted. Next, move on to the next problems. The following data is given for a rope pulley transmitting 24 kilowatt. The diameter of the pulley is equal to 400 mm, speed 110 rpm, angle of groove 45 degree, angle of lap on the smaller pulley 160 degree, coefficient of friction 0.28, number of ropes 10, mass in kilogram per meter, length of the rope is 53 c square, and the working tension is limited to 122 c square kilonewton, where c is the girth of rope in meter. Find the initial tension and diameter of each rope. First write down the given details, that is transmitted power PT is equal to 24 kilowatt, diameters range. Initial tension, we know that the power transmitted P is equal to total power transmitted divided by the number of ropes. Total power transmitted, that is 24 kilowatt divided by number of ropes. Number of ropes is equal to N is equal to 10. So power transmitted per rope is equal to 2.4 kilowatt. So velocity of the rope V is equal to pi d n divided by 60. Substituting these values for getting the velocity 2.3 meter per second. Let us T1 and T2 are the tension in the tight and the slack sides. We know that the power transmitted per rope P is equal to T1 minus T2 into V, 2400 in terms of T1 minus T2 into 2.3. T1 minus T2 is equal to 1043.5 Newton. Taking this at equation number 1, we know that 2.3 log of T1 divided by T2 is equal to mu theta cosecant beta. By solving this given details, that is mu theta cosecant beta values and 2.3 logs, we are getting the T1 divided by T2 is equal to 7.786. that is equation number 2. By solving equation 1 and 2, we are getting the tension in the tight and the slack side of the belt, that is T1 is equal to 1197.3 Newton and T2 is equal to 153.8 Newton. We know that the initial tension in the rope, that is T0 is equal to T1 plus T2 divided by 2, that is initial tension is equal to 675.55 Newton. Diameter of each rope, that is D is equal to diameter of the each rope. We know that the centrifugal tension TC is equal to mv square. We already know that mv square in terms of 53c square. We already find out 2.3 velocity, m in terms of 53c square, and working tension 122 into 10 power 3 c square. By solving these equations, we are getting the c is equal to 0.0992 meter, that is 99.2 meter. We know that the grid, the circumference, that is circumference of the rope, c is equal to 99.2 is equal to pi into d1. So d1 is equal to 31.57. So we all find out the diameter of the each rope, that is d1 diameter of the each rope is 31.57 mm. Thank you.